All right, welcome everybody to Full Momentum, an HEC-RAS vodcast. My name is Ben Cary, and joining me here as always is Chris Goodell. Chris, welcome to episode 9 of Full Momentum.
Thanks, Ben. It's good to see you. It's been, a couple weeks, I think, since our last one, so it's long overdue. But
Definitely, yeah. We've been,
it's summertime. It's busy, right? A lot of things to do, and
yeah,
uh,
exactly.
I've taken some time off. I don't know if you have over this last few weeks, but
Not as much as I would like to, but yeah, it's
yeah, I know.
it's summertime. We're busy at work, and we're also busy outside of work. Speaking of that, one of the things I
Mhm.
wanted to pick your brain on, Chris, is just to give the folks listening today a little bit more background on us. What's your favorite hobby? Outside of work, outside of hanging out with the family, what is something that you really dig doing that maybe would surprise somebody?
So HEC-RAS modeling counts as work?
No, yes, yes. This cannot be modeling related. No modeling relation
I'm
here.
kidding. I'm kidding. Yeah, I don't want people thinking I do this all the time. Although I do it a little bit on my own spare time sometimes. But no, you know what I like to do, and this is not going to be a specific thing, but kind of more of a general thing. But I like doing woodworking stuff, like stuff in my shop, and
Okay,
it doesn't even have to be woodworking. It can just be I like making things. I don't know if you've seen that show, Making It.
I have
Um,
not.
so there's this new TV show. Wow, it's not so new anymore, but it's one of those kind of contestant shows. But it's about making things, and so I like producing things and using my hands and doing manual labor. It could be anything from making a dining room table to right now I'm restoring a horse trailer, and I'm also adding a bedroom in a rental house. And so I just love doing those things that, those tactile things where you have something that you've created or you've improved upon there on display that you can clearly see what you've done at the end of it. Love doing that stuff. And just the manual labor side of things is a complete 180 from what we're doing on our
Mm,
desks all day. And so there's some days where I cannot wait to jump out of my chair and get out of the house, go to my shop, and start using my hands and working on things.
yeah,
So
that's
yeah,
great. And I know one of the things that you've been able to show me. Another thing you enjoy making is wine, which is
yeah,
another kind of example of that. Making some with your hands, and I've enjoyed
yep.
doing that with you in the past. That's a much more productive hobby than than I think mine is. My definitely my thing that I can't wait to get out of the chair at the end of the day for is yeah, I'm was an athlete in high school and played club sports in college, and so always been very competitive and athletic in that way. But over the last couple of years, the sport that I've definitely like kind of totally fallen for and do a lot of is pickleball. And I know that we've talked a little
Mm,
bit about that in the past,
yeah.
but pickleball definitely eats up a lot of my time. My wife has started playing it as well, so that's been fun. But
I want to play sometime. You're gonna have to show me how sometime.
I
We'll
think
get
that
a
would be a
tournament
really
going.
fun thing to have a little Kleinschmidt outing and play a little pickleball. For those of you guys who are listening that aren't aware, definitely look up pickleball on YouTube. There's some great videos on there to give you an idea of what the sport's like. I always tell people it's like tennis and ping pong had a love child, and that's pickleball. So it's a smaller version of tennis. It's very quick reflexes. And it's a lot of fun. Normally play with 4 people, so I've made a lot of friends outside of work through the sport, which has been really great, and it keeps me active. This time of the year, it's unbelievable. We live in a great place in the country for outdoor recreational activities, and this has been kind of my latest passion that I really kind of dove headfirst into. So.
Correct me if I'm wrong, Ben, but pickleball has nothing to do with pickles.
No, that's correct. Pickleball, the name
Okay.
is kind of funny. The name is based on the family that invented the sport on Bainbridge Island in Western
Which is
Washington.
where you grew up.
I grew up on Whidbey Island, so
Oh,
different
Whidbey,
island.
that's right.
Well,
Close though.
yes, yes, we
Neighboring
don't.
islands.
Yes, we played a lot of pickleball growing up, being an island in Western Washington. But the family that invented the sport, their dog was named Pickle, and when they were playing it, I guess the dog would chase
Ah,
the ball around, so they named it pickleball. So yeah, fun fact.
very
Uh,
cool. All right.
so for those of you guys who are listening to this, we'd love to hear about what your hobbies are outside of work. Obviously, this podcast is highly technical. It's focused on what we do on a day-to-day basis. But we love to kind of get to know our listeners and interact with folks. So feel free to post in the comments what you enjoy doing, especially this time of year with the great weather we have going on. Get an idea for what our audience likes to do outside of HEC-RAS. And please don't say your hobbies is HEC-RAS.
Yeah, but let me tie HEC-RAS modeling into both of our hobbies, which is everyone who's done enough HEC-RAS modeling has gotten stuck somewhere, whether your model is
Mm,
crashing, it's going unstable, you can't figure out how to set it up to model a certain situation, and you just feel stuck. You're just not getting anywhere. Go out, get away from your computer, go play some pickleball,
mm,
go build something, use your hands, go mow the lawn, do something physical, and that'll kind of reset your mind. And it's amazing how many times that's helped me to kind of clear out all the old stuff that I was trying to use and think about to solve my problem. It's just brought in some new solutions, and it's amazing.
yeah.
That and dreaming sometimes helps too.
Good, good,
But
good. Yeah, I think those are both great suggestions. So
yeah, yeah, yeah,
fun stuff. All
yep,
right, so
cool.
now we get into dive into the technical topic for today, and we kind of have two of them. One is more of a news story that's also a little bit technical, and then one of them is an actual demonstration that Chris is going to go through. So we're going to start with the news story that is a little bit more technical based, and that is an exciting announcement that came out a few weeks ago. And I heard about this through ASFPM, which for those of you guys who don't know is the American Society of Floodplain Managers, of which I am an active member, being a certified floodplain manager. And they made an announcement that in collaboration with FEMA and a number of other agencies, there has been there is finally going to be a standard for doing 2D modeling of floodways, specifically
Mhm.
related to remapping of FEMA special flood hazard areas. Which, for those of you guys who work with FEMA and floodway analysis, you'll be familiar with that. For those of you guys who are not, the idea is most waterways in the United States are mapped for flood hazard level based on the frequency at which different flood levels occur. And up until now, one of the primary parts of that analysis is doing a floodway analysis, which is analyzing the portion of your river channel that is most efficient at carrying flood flow and developing that on a map and making sure that there's no development that occurs inside of it. And up until now, that process was really required to be done in 1D modeling, and that's because when this initial process was developed, 1D modeling was really the only modeling that was available. But given the fact that there's been such huge strides made with 2D modeling, there's been a push over the last couple of years to come up with some sort of standard so we can utilize the power of 2D modeling in the modeling of floodways. And that's something that
Mhm.
uh, is coming down the road, and that's what we learned in the last couple of weeks. So I'm just going to share a few things here. First off, the presentation that was given in regards to this. So this is a presentation that myself, as well as a few other engineers from Kleinschmidt, attended and listened to. Again, this was given by a combination of people that work for ASFPM and FEMA, just giving people an idea of, hey, this is what's coming down the line. Give people some time to prepare for the different guidelines that are going to be coming out soon, which was really cool. So the presentation, again, it was literally called 2D Floodways Proposed Revisions to FEMA Floodway Guidance. This is very much in the proposal stage. They're still brainstorming how this is going to be put together, but the goal is to have something published by the end of 2020. So hopefully by 2021, you will have the option as a consultant to submit floodplain and floodway revisions using 2D modeling, which is really, really cool.
Mhm.
Again, like we talked about, one of the biggest hurdles, I'm going to skip over a lot of this, obviously. I will post a link to this presentation in the comments of this podcast, so you guys can go and review this yourself if you already haven't, or if you hadn't heard about this announcement that came out. But like we talked about, one of the, I guess, more complicated aspects of coming up with this approach is how to figure out how to delineate your floodway, how to do an encroachment analysis in 2D, because in 1D it's pretty easy to do, or it's pretty well established how to do that. But in
Well,
2D there's still,
yeah, the whole process is inherently one-dimensional, right? I mean, which is the whole problem why we couldn't ever come up with a way to do it in 2D.
yeah, and
Isn't that
so
right?
there's still a lot of uncertainty as far as how the best way to do this. So I imagine what's going to happen is they're going to come out with some standards that will be pretty general. They'll leave it kind of up to the consultant to come up with what's best, and then the review team that reviews any sort of map revision request is going to dive into those and see how reasonable they are. But some of the things that are being considered, which kind of tie directly into HEC-RAS, is going to be using some sort of hazard mapping to get an initial idea of where the floodway likely will be. So an example of that would be like the map you see here on the right, a depth times velocity map, which is a common way to analyze hazard classification of a river or any type of floodway, and using the D times V map to come up with an initial estimate for where the floodway might be. And then from then there's been discussions about how to come up with the official encroachments after that. And a couple of things that have been brought up, one would be actually editing the terrain so that you're coming up with more or less a blocked obstruction, but in 2D. So actually not allowing water to escape based on your underlying terrain of your 2D model. Another way would be using really, really high conservative Manning's end values in the overbanks, such as the second figure over here, just to really limit the amount of flow that's being able to access that. Now, there's some issues with that, obviously, because you're still going to be counting storage when maybe you shouldn't. And so these are all just discussions that are taking place right now. They wanted to bring these up in front of hundreds of consultants that were on this call to get some feedback and ideas on what they were thinking and what would be best. But eventually later this year, we'll have a standard and a way to actually do this in the real world, which is really cool. It's going to be really interesting to see how it works out. I'm sure, like anything, when it comes to a new set of regulations, there's going to be some bumps in the road and some lumps that folks have to take when it comes to this stuff. But hopefully, it'll bring us closer to being able to utilize this really, really cool two-dimensional hydraulic modeling software that we know is much more appropriate in a lot of applications than 1D. And I know that there's folks and consultants in, for instance, Texas right now, Chris. I know folks down there that are kind of on the forefront of this and really pushing, if not actually using this already, to come up with their flood maps, because of how two-dimensional a lot of the flooding can be down in those really, really flat areas.
Yeah, that's correct. That's correct. And I'd be really interested to hear, for the folks who are listening out there or watching this podcast, if you're in another country and you have something similar, if you have a similar program or you do similar analyses as what we're talking about, the floodway analysis here in 2D, how do you do it? I know in Australia, and it's even listed there in the fourth bullet item down there, the Australian curves. But my understanding is in Australia they use a sort of a hazard classification or a DV type of process to come up with their floodways, or their equivalent to floodways. But I'd be interested to know how it's done in other countries, but also for folks who may be using this in the future. What do you like that you see here? What are some ways you think will work well, or you're interested in, or you think should be the way to go, whether it be DV maps or heightened N values, or maybe some other way, putting in structures to separate out the floodway and the floodplain area. So
yeah,
leave some
definitely
comments.
an interesting conversation. We'd love to hear more about what folks are thinking. And like Chris said, if other countries have this, maybe even if they have some sort of standard that's been developed, share that. We'd love to read that and have other folks have access to that, just to kind of get everybody up to speed on this, because the reality is in 6 months there's likely going to be people that are going to be submitting Lomer and Clomer analysis that's based on 2D floodways, which is new, it's exciting, and it'll be really interesting to see where it goes from there. So as
Yeah,
far as what
definitely.
this means moving forward, I think it's just really important, if folks are interested in this, or they're eventually thinking that they might actually be doing this type of work, do some research on the front end. Go to the link again that's going to be in the bottom of this video to look over this presentation. The presentation is also recorded if you want to rewatch it. Keep an eye out on the announcement that's going to come out later this year when those regulations are finally posted, because once those are posted, it'll be kind of be the Wild West as far as folks wanting to do this type of work. Reach out to Chris and I. Reach out to HEC-RAS at kleinschmidtgroup.com. Ask us if you have any specific questions, or if you're interested in us helping you out on projects. Again, this is kind of right up our alley. It's 2D modeling, and it's FEMA floodplain work, which is something that we're very comfortable doing. So if you have any questions, feel free to reach out to us. And then lastly, if you yourself want to get more comfortable with 1D and 2D modeling, take our HEC-RAS class. Again, I believe, Chris, correct me if I'm wrong, but that class is going to be starting October 11th.
Yeah,
Or
it's in
early
October.
October.
Yeah, it's in October, so it's coming up quick. I don't know about you guys, but being working at home seems to make time go by fast for some reason. I didn't think it'd be that way, but anyway, it's coming up quick, so don't hesitate, don't delay. Sign up. There will likely be a limit, so you don't want to wait till the last minute to sign up. And yeah, you can find that on our webpage, kleinschmidtgroup.com.
Yeah, absolutely. So, yeah, that was kind of the news story for today. Before we get into the technical topic and the demonstration that Chris is going to do for us, I just want to take this time to thank our sponsor for this episode. So Chris and I are super thankful to be sponsored by our firm, Kleinschmidt Associates, who is known throughout the industry as a firm that provides practical solutions to complex problems affecting energy, water, and the environment. You can learn more at kleinschmidtgroup.com.
Super fun place to work too, by the way.
Absolutely.
Let me
Super fun
say.
place to work, always hiring. Uh, so
Yeah.
keep an eye on job posts coming out. We just hired another H&H engineer out of Virginia Tech. So we're excited to have him on the team. But yeah, great place to work.
Yep.
Cool.
Definitely.
Well, let's dive into the technical topic today, Chris. So
Yeah.
I believe you're going to be leading us in a discussion on cross-section interpolation, which is a great topic.
Yeah. So cross-section interpolation is a tool probably used more than just about anything else I've used in the geometry window. It's a common part of building a model, and it's a great way to achieve numerical stability. But there's some do's and don'ts that you need to know about interpolation, and it's not incredibly intuitive. It's a pretty easy tool to use, but there's some things that maybe you've always wondered about, and I'll try and cover those right now. But let me open up the Bald Eagle Creek data set. Again, I like to mention to folks that this comes with the software. So everybody has this data set. If you want to play around like I'm doing right now, all you have to do is go find out where it was installed when you put the software on your computer, and you can play around with it. And this has a really nice terrain too, which is makes it very useful for trying things out. But today I'm going to show you cross-section interpolation. Right now you see we've got a 1D reach, a lot of cross sections through here. And there are no interpolated cross sections, and I know that because the interpolated sections are a lighter color green, first of all, and the river stationing number will have an asterisk next to it. That's how you know it's interpolated. So currently in this model, there are no interpolated sections, but sometimes you need to have more cross sections, and a lot of times it has to do with just numerical stability, so unsteady flow modeling. Why do you want to have more cross sections? Well, the first and foremost reason is to be able to adequately describe the geometry in your system. So anytime you have a change in width of your cross section or change in shape, You want to have cross sections to help define that change in shape. But also if you have change in land use, because that's a value that's added to your cross section, end values. And so if your end value changes, you're going to want to have a new cross section to define where that change happens. Also, a change in slope. You can't really see the slope here in this figure, but if I were to open up the profile plot, you can see the channel slope. If you had a significant change in slope or a grade break somewhere in here, typically you want to have a few more cross sections around that, because the hydraulics are changing usually over that grade break pretty quickly, and so you need more cross sections for that. You may just need more cross sections because the numeric solution requires it. And so if you're running an unsteady flow model, there's a certain spacing that makes the model happy. And there's a couple ways to figure that out. A lot of it really just boils down to your own experience. But there's Samuel's equation out there, which is a good one to use for unsteady flow models. And I've used that quite a bit. You can find that on the rassolution.com. There's also, if you're doing dam break modeling, there's an equation by Danny Fred out there that's useful. But this will give you a first cut, but really a lot of it's just practice and experience. But if you do find that you need more cross sections to satisfy a numerical requirement, you can do interpolation. And interpolation is found right in the geometry window. Under the tools menu item, you can see XS interpolation. It's the first one in the list. And there's two methods. There's doing interpolation within a reach or between two specific cross sections. If you choose the first option, within a reach, you can do interpolation over multiple cross sections. In fact, you can do the entire reach. You can go from the upstreammost cross section all the way to the downstreammost cross section, and then you can put in a maximum distance between cross sections. Let's say right now they're on average about 2,000 feet apart, or it could be meters. And I want to maybe bring that down to a maximum distance of 500. So you just put 500 in here like that.
Oh, Chris, I'm not sure I can see the cross-section editing that you're showing.
Yeah,
there you
sorry
go.
about that. Had it on the wrong screen. Yeah. So here's the interpolation by reach. And right now I've got a 500 maximum spacing put in there, and then you hit the interpolation button. And once you close this, you'll see now I've got a bunch of lighter green cross sections. These are all interpolated sections in there. And I'm going to change the resolution really quick on my computer because I want to make sure you guys can all see this.
So Chris, is it reasonable to, one of the things I've heard is that cross-section spacing is similar to cell size in a 2D model. And what I mean by that is, in the same way that sometimes you want to change your cell size to represent either more detail or to satisfy some sort of computational requirement, sometimes for and similarly you want to change your cross-section spacing, and those things are kind of tied together pretty closely. Is that accurate, or is that an inaccuracy?
Yeah, absolutely, that's accurate. It's the same thing. It's whenever you have a significant change in hydraulic parameters, whether it be change in depth, stage, or change in velocity, that having more computation nodes helps get through that and produces a better answer, a more accurate answer. So
in the same light, is it similar to 2D modeling in that when you have smaller cells, you inherently need a smaller time step in order to satisfy certain computational requirements, or is that not the same?
No, it's absolutely the same. So the Courant condition applies on cross sections just as it does with 2D areas. And so it's a little bit less restrictive in 1D reaches than it is in 2D areas, but the Courant number or the Courant condition is a great way to help pick a computation interval after you've selected or settled in on a cross-section spacing. So that's typically the order of how things are done, is you get your cross-section spacing figured out, and then you use that to help determine your computation interval.
Okay.
Yeah, so great questions. And notice here with the by reach method, I've got cross sections along the entire reach. Let me zoom out a little bit and you can see I've got interpolations all throughout. Now let's say that I want to get more specific. Maybe I'm just interested in cross-section interpolation between two specific cross-sections, or I want to have more control over how the interpolation is done. I can use this other method called between two cross-sections. Okay, and you get a slightly different window. There's a lot of similarities, but
Mm-hmm.
notice here, first of all, you have this graphic down here which shows you two cross-sections,
Mm-hmm.
the two bounding cross-sections that will interpolate between. Okay, let me get this positioned where I want to have it. So I'm going to zoom in. Let me close this really quick. I'm going to zoom into this location right here. And first thing I want to do is actually delete those cross-section, those interpolated cross-sections. So I'll go to within a reach, and then you'll notice there's a delete interpolated cross-section. So it's a very easy, quick, convenient way to get rid of cross-sections.
Mm-hmm.
Now, let's say I want to interpolate between these two sections right here specifically, and I want to have more control over how I interpolate. I want to have a little bit of control over preserving features in the interpolated sections. Let me show you what I'm talking about. First, you would go to between two cross sections. And again, here's that window that I was showing earlier. And now we see the two cross sections we're interpolating. Now we can move around the reach, but you're always limited to interpolating between two cross sections. Okay, so this is the spot that I want to interpolate. And there's a few more options in here you'll notice. First of all, we have more ways to interpolate. Before we could only just do a maximum distance. But with the between two cross sections option, we can actually interpolate to a constant distance or to a specific location. Let's say there's a spot in here that I want to have a cross section on, but I just want one and I want it in a particular location. I can do this set location and just put the distance downstream from the upstream cross section,
Mm-hmm.
and that'll place an interpolated section there. The other thing I want to point out here too, and in this graphic, it's a little bit confusing because the upstream cross section is right here on the top and the downstream is here. So we're actually looking in the upstream direction, which is the opposite convention that we're used to in just
Mm-hmm.
about everything else in HEC-RAS. Normally, we want to consider, we want to think about looking in the downstream direction when we're looking at left and right. And so when you're looking at this interpolated, the interpolation graphic here, keep in mind, this is the left-hand side. This is the right-hand side of the channel because this is the upstream. And if you're looking in this direction, the downstream direction, that would be left, that would be right. Okay. And so I point that out because I'm going to make this window a little bit smaller here, because there are some features in here you can see in these interpolated sections. Notice this right here, this high ground feature right here in the left overbank, flow's going this direction, right? Left overbank, that would be this side. Here you can see that feature clearly
Mm-hmm.
shown right here and right here. This is the upstream cross section that's a little bit further away from the main channel than this one, which is a lot closer, right? Now, this is a common feature between these two cross sections. But if I were to interpolate between these two, let's just do 1,000 feet and maximum distance and interpolate. Notice this ridge line fades away and this one fades away in this direction. But they show up in the interpolated section as two separate ridges, right?
Mm-hmm.
When in reality, they're the same. And so what we need to do is put in what's called a major chord. This is a user-defined major chord. And this is how we can connect common features. Click on this button right here and just draw a chord from here to here. And RAS will now know that that's a feature that is common between these 2 points, and it's going to preserve that in the interpolated sections. So watch what happens now when I interpolate. Notice here now
Yeah.
that feature is preserved from one cross section to the next, just like it is over here.
Yeah,
But
and
now,
there's certain features that you know won't be able to capture. Like Chris, for instance, if you look at that at the upstream end of that cross section on the right overbank, there's a little bit of a bump,
yeah, right
and
here.
that's
Yeah,
not captured in the cross section that's upstream of that. And so you know that's something that you're not able to preserve, and that's okay. You know, you don't need to capture every feature when you're interpolating cross sections. Again, we're using approximate methods already. We're assuming, you know, the flow can be represented by these one-dimensional cross sections, and so it's okay that you don't capture every feature. But like Chris said, it's important when you have continuous features that those things are captured and consistent, and using those chord connectors can be really key in that.
exactly right. Notice now when I bring it back, oh gosh, what did I do there? I was trying to work too fast.
You
Okay,
caused it
hang
to
on.
crash.
Yes, it happens.
Yeah, it's a good example that anytime you have an error, it causes RAS to crash. You're not the only one. Even experts have that happen to them all the time. So.
That's right. That's right. The key is remembering what you did to make a crash and don't do it again. So let's go back into the interpolation and notice I bring it up and that actually I'm in the wrong spot here. One of the cool things is so notice it started at the upstream end, but let's say I'm interested in interpolating here. If I just click on this cross section,
Mhm.
now RAS will recognize that I'm interested in that. And so when I go to interpolate, it's going to start at that spot.
Yep.
Yeah, so that's a quick shortcut way to get there. All right, and here's that feature Ben was just mentioning, that little knob rock or something, whatever you want to call it, in the right overbank, right there.
Hmm.
And so that's picked up on this cross section, but not this one. And so that's why it's important to understand how these cross sections are laid out in the interpolator, that this is the upstream cross section, this is the downstream. Okay, because here's that feature right there. We can clearly see it if I move the window out of the way right there, but it doesn't show up there. So we would not want to have a major chord in this case. We would want to see that feature diminish. So let's do this major chord over here again, but we'll not do one there. But here's another one. Look at this. See this road right here and this road right here? Common feature. If you look closely, that shows up right here as this little blip. Okay, so I'll do a chord there, and then I'm going to interpolate to 1,000 feet again. And there we go. Now see, this thing fades away, and you could actually get a little bit more precise with it and make sure that, you know, if you have a cross section right here, it doesn't include any of that feature on it.
Hmm.
So you can get a little bit more precise than this even, and that might be where you might select a constant distance, for example.
Yeah. Yeah, and I think you know this is a great example of kind of what we've talked about in the past when it comes to 2D modeling. In that you have to ask yourself, what's the purpose of your model? How accurate do you need it to be? Because that's going to dictate how much time you want to spend doing this stuff. Sometimes you just want to, you know, a quick 1D model, or you're doing a breach model where these little tiny features aren't not going to make any difference in the big picture, and it's probably not worth the additional time to take to do this. But there are certain studies where it's going to make a big difference, and so you really need to pay attention to it.
Yeah, great points, Ben. And another thing I want to point out is notice the cut lines
Hmm.
of these interpolated sections. They don't look right, correct?
Hmm.
And that's because RAS also interpolates the cut line coordinates. And so you can see it's kind of interpolating between these, you know, these vertices that you see here in these bounding cross sections. But it doesn't look at the main channel or the river center line when it's doing this by default. But there is another way to interpolate, and sometimes it works a little bit better than the default. And that is to use this generate for display as perpendicular segments to reach invert. Now, this works very well if you don't have dog-legged cross sections. We have a lot of dog-leg cross sections in here, so it's probably not going to work so well in between here. But the theory is what RAS will do if you select this option is it's going to follow the channel center line. It's going to interpolate cross sections that are perpendicular to this line in between. And so if I select that option and do this again, I won't bother with the major chords just to save time. And interpolate. Now notice it actually did get perpendicular for the main channel, but look at the overbank parts. The dogleg parts are all messed up and they're overlapping.
Yep.
This would not be a good result here. So we wouldn't want to use this. So let
Yeah.
me
So
delete that. Yeah, go ahead.
So this particular situation, you know, you've tried it the basic way, using the linear interpolation. You've tried using the perpendicular segments. Neither of them worked. You've identified that you do want to capture that bend accurately because of the particular project that you're investing in. And so to me, this would be a time when you'd say, okay, I can't use interpolateds anymore. The best thing for me to do is probably going to be to generate my own cross sections between these two in
Yep.
RAS Mapper, extract the station elevation based on your underlying terrain, and then go from there.
Absolutely. You read my mind, Ben. That's where we were going. So, you know, interpolation, the interpolation tool doesn't always work perfectly. And I just showed you an example of that. Furthermore, the terrain in between is not captured on interpolated cross sections. The terrain that's used on interpolated cross sections is just an interpolation between this cross section and that. And so RAS doesn't know about anything in between. So one thing you could do before I go into RAS Mapper is you could interpolate those sections. Let me do that one more time real quick.
Yeah, maybe do it on a one that's a little bit more linear, Chris, so it make a little bit more sense.
Yeah, that's a good idea.
Because I know where you're going. And I think that's a valuable idea.
Let's go down to this. This is a little bit better.
Yeah.
All right, so I'm going to interpolate here. The spacing is 838 feet. So let's go back down to our 500. That's just going to give us one cross section in between. And there it is. Now I could do some major chords here too, and probably should, but for expediency, I'll leave that there. Now we've got a cross section that actually looks really nice here. It interpolated those cut lines very well. But if I go and look at the cross section editor, let me make this a better size to look at here. And I've got plot terrain turned on. Notice that my interpolated section, which is the dark gray line, the thicker gray line, is not lined up exactly with the actual terrain. And I can zoom in and verify that, right?
Yep.
But what I can do is now that I've got this cut line here, if I really want to keep the terrain, I can just go,
I think it's one of those that's hidden right now because you're
yeah,
minimized it.
I was going to say, where did that
There you
go?
go.
I
It's on
know
the
it's
right,
there.
right there.
There
You
it
can
is.
see it's hiding.
Thanks. You can hit this cut from terrain button. And now I've effectively just cut right off of that terrain. And the only way that's going to work is if you have a terrain that's associated with this geometry, but we did already. And so now notice it's no longer an interpolated section either. So RAS recognizes, hey, I cut that from terrain. This is not an interpolated section anymore. This is a real valid cross section. But to your point, Ben, if we wanted to add some more resolution around this bend, a few more cross sections so that we could interpolate better, or maybe we don't even need to once we add cross sections, you can always go into RAS Mapper and just add cross sections right in there. And so I'm just going to go to this test geometry, which is right here. Let me turn off the other one. Rivers cross sections. There are my cross sections. Let me get to the spot that I was talking about. It's way down here. Okay, it's right there. I can just go in, right click, edit geometry. There's my toolbar up there. I want to add a new feature, so I click on that, and I can just remember draw from left to right as if you're looking downstream. I'm going to try and get one right on this, the apex of this bend. So go like that. And then, you know, try and think about how flow is going to be moving through here and keep your cross section perpendicular to your perception of what the flow lines will be.
Yep.
Okay, maybe I put one more right here too. Something like that. Okay, and then actually I want to compute first, so I'll just compute, let me just compute those two. So I'll just highlight those two.
Yeah, so you need to
Oop.
select your selector. There you go.
Highlight those two, and then right click, compute all attributes.
And then one last thing you'll need to do, this is important when it comes to drawing in those cross sections, you also need to recompute the reach length of the upstream cross section.
Yeah, that's right. So I should probably
right click on that. Yeah.
I should probably compute reach lengths on that one. Yep. Good point.
Yep.
That's a good thing to remember, because
Yeah, that's something that
now
I
that you've
often miss
added,
too. So
yeah, you've added these in here, so these reach lengths need to be updated. Yeah, good point. All right, so now I can go and stop editing, save, yes. Okay, it gives me a little warning that some of these other things may have been affected by the river stationing. And then close this. And now you can see that I've got some new cross sections in there. All right, and so there we have our cross sections that we drew in RAS Mapper. They're now showing up here. And if we went to Interpolate, I can tell you already, it's not going to be perfect right between here and here. It might be a lot better right here though, but it's going to be better, and probably needs one more cross section. But by that time, you've already got a lot of sections in there. Maybe you don't even need to interpolate anymore. But that's just something that's good to know. Again, cross-section interpolation, there's two methods: within a reach, between two cross sections, and just play around with it. It takes a little practice. The most important thing, though, I think, to remember is that this is the upstream cross section, this is the downstream cross section. Okay, so it's a little backwards from what you're used to convention wise.
I also think this, using the interpolated cross-section tool is similar to doing 2D modeling in that it's pretty easy, it's pretty quick, anybody can do it, but it can cause you some issues. So it's always really important to make sure that you do inspection of your interpolated cross-sections after you're done with the interpolation. Make sure you're comfortable with how the model is displaying those. If you need to make any revisions or delete some, or maybe draw some more customized cross-sections in, it's really important to do that kind of post analysis once you interpolate, because you can get yourself into a little bit of trouble because of how easy it is to set up.
Yeah, I just did one real quick, a constant distance one. You can see it didn't put it in the middle because it put it 1,000 feet downstream from this cross section, right? Mm-hmm. Here's one thing I want to show really quick too, because I get this question a lot. Well, is there a way to uninterpolate a cross section? In other words, make it a real cross section, not interpolated. And there's some reason why you might want to do it. Probably the main reason is because you can't interpolate between an interpolated cross section and a non-interpolated cross section. You can only interpolate between two regular cross sections. But if you wanted to say interpolate between these two, you could just go to the edit cross section and go options, rename, and take out the asterisks. And this is a way to trick RAS into thinking this is now a real cross section.
Yeah, but you could do that, or you could also cut from the terrain like we did with the previous one. And that's probably better off doing, because if you were reviewing this model, you would have no idea that that was an interpolated cross section at that point. And if you open the geometry back up, you'll see that it doesn't match the underlying terrain. So that could get you into trouble as well.
Yeah, and whenever I do that, by the way, if I uninterpolate a section, I think this was the one. Yeah,
it was. Yeah,
I always put in the description interpolated. That way I know later on, if I'm coming back, that even though this looks like it's a real cross section, it's interpolated.
Yep, that's a great suggestion.
Yeah.
Cool. Well, I think one of the questions I had, Chris, when you were talking about that came up is, or I guess maybe more experience than anything else, is some of the downsides of interpolated. We already talked some about these, as far as the downside of some using interpolated cross sections can be when you're using the linear interpolation assumption. You can kind of have your bank stations and your cross sections not placed in the correct location based on where flow is actually moving. That's a downside we talked about. It's going to be really challenging to capture the true cross-section geometry around sharp bends. One of the other things that we touched on a few episodes ago when we were talking about Manning's N value is that if you have some pretty varied or some multiple different kinds or spatially varied Manning's N values in a cross section, and you do interpolation between those, you can end up with 10, 20, 30 different segments of Manning's end value. You can get really crazy really quick if you use the interpolated cross-section methodology for that. So when you have Manning's end values that have some spatial variation to them outside of just the normal left over bank channel, right over bank, be very wary that when you use the cross-section interpolation tool, that your cross-section results can get kind of crazy. So.
Yeah, and that's why, yeah, exactly. I mean, having too much definition can really cause trouble with you because, yeah, end values are interpolated too. And by the way, ineffective flow areas are interpolated.
Yeah.
So
Another really important reason to do some post analysis of your interpolated cross sections when you're done.
Yeah. Hey, you know what's not interpolated though, Ben? I bet you know this though. Blocked ineffective areas.
Nice. I actually did not know that. So
yeah. So if you put in these options, ineffective flows, and you make these multiple blocks,
yes,
those will not be interpolated. The normal ones will, as long as you have them on both bounding cross sections, but multiple blocks will not. So something else to keep in mind too when you're interpolating.
Yeah, absolutely. Cool. Well, that was a great discussion, Chris. I think it's going to be super valuable to folks out there that maybe haven't used interpolate cross sections or have, but haven't really unlocked the true power of those, especially when it comes to connecting some of those unique features. I think that's a really, really important thing to do. It's pretty easy. One thing one other final note is, when you have hundreds of cross sections in a model, doing interpolation for those and manually editing each one can get really cumbersome. So,
Yeah, for sure.
if you really need that many cross sections to capture some unique hydraulic aspects of the model, you might ask yourself if maybe you should be doing 2D modeling in that instance. It's not a guarantee, but it's a question worth asking.
Yeah, and the other thing too, now that we have terrains and most of us are doing georeference modeling with the terrain in the background, it's almost too easy to add cross sections that way. And sometimes I wondered, why even do interpolated sections? Just go and draw some new cross sections and call it good.
Yeah.
And in fact, some clients will require that you have real cross sections. Not too long ago, we didn't have terrains to cut cross sections off of. And if you needed a new cross section, you had to send a crew out to the field to go survey it. And that was very expensive and time consuming. And so that's when this interpolation tool was really beneficial. But
yeah, I think the most helpful application that is still relevant for today is when you have cross sections that are very similar in shape. They're not too far away from each other. And maybe there's just a really, really complicated hydraulic issue going on. Maybe it's coming up on a bridge, or it's, approaching some sort of really dynamic flow situation, a really fast flow situation where you just, or maybe it's downstream of a dam where you have a dam breach occurring and you need to add interpolated cross sections. And those interpolated cross sections aren't going to be that much different than what they would be if you cut them from the actual terrain. That's, I think, when this is most useful. It's still probably most applicable, and you're not going to get yourself into trouble doing it. At least in my opinion.
Yeah, that's exactly right. And sometimes when I just want to check out, hey, what kind of spacing do I need here to capture the hydraulics? This is a quick way to figure out the spacing you need, and then you can go back and actually cut cross sections where you want them to follow that spacing too. So yeah, this tool will never go away. It's always going to be a very useful tool. But yeah, I think we'll be doing more and more just cutting right off of the terrain in the future. So great. Ben, I lost your audio.
Thank you. Before we take off for today, Chris, is there anything else that you wanted to add? I think we covered a couple really interesting topics. Specifically, I know with the 2D floodway analysis, that's going to be, a topic that over the next 6 months we'll probably talk about again, especially when those standards come out. But anything else stand out to you before we sign off for the day?
No, not really. I like this feature in RAS. I'm glad it's there. It's very useful. I've used it a lot, the interpolation. And I would just encourage people watching to tell us what you think about interpolations. Do you have questions about it? But also, we're always looking for, what do folks want to know about? I mean, Ben and I know what we want to know about and what we think people want to know about, but if you let us know what's interesting to you, we've already been getting some examples, and we will add those. We'll include those in future podcasts. But keep them coming.
Yeah, actually, I want to encourage everybody, if you posted a question on our YouTube page underneath these videos, and we haven't actually addressed it in the comments, we've recorded it, it's stored in our question bank, and we're kind of going through those as we speak and coming up with which ones do we want to tackle with just responses on the page, which one do we want to actually maybe do episodes on. So keep posting those. We see them, they're getting filed away, and we'll eventually hopefully get to all of them at some point. So
Yeah.
awesome. All right. Well, if that's all, then this has been episode 9 of Full Momentum, an HEC-RAS vodcast. Thanks, everybody.